gives you a base secant or cosecant graph and then uses transformations on that. I do a completely different method. Okay, I do something called a related graph. Let's start with a cosecant. So if you have y equals a cosecant of dx minus c plus d. Now, the book's method is to look at this in terms of transformations of your regular cosecant graph. I'm not going to do that. What I'm going to do is a completely different graph that I call a related graph. This is just my terminology for it. You won't find this in the book anywhere. Okay? The related graph is you change the cosecant to sine, and you leave everything else the same. So if I give you a cosecant function, change the cosecant to a sine, and that gives you this function called the related graph. Now what you're going to do is graph this. And so, you know, who knows what it really looks like, but so you've got, maybe it's shifted and everything, so you've got, you know, some sine wave, reflective or shifted. You've got your center line in there. So this is just the graph we've been working on with sine and cosine. Okay, in this case, sine. Now, to get, that's this function right here. To get back to the original cosecant function, what you do is, everywhere you cross the center line, you put a vertical asymptote. Everywhere your sine function crosses the center line, you have a vertical asymptote. And they will be equally spaced apart. The spacing apart will be exactly half of period. So we'll talk about these things later. And then you just fill in between those with either U's or upside down U's. In this case, they alternate. And this graph I'm making in light blue is our cosecant graph. Right. Exact terminology. Okay, now, if you want to check this on your calculator, you have to remember that cosecant is the reciprocal of sine. So we would replace this right here with 1 over sine of dx minus c. So the a can slide up on top. You would have a over sine of dx minus c plus d. What I'm trying to show you is this thing I'm calling the related graph. It's not the same, and it's not the reciprocal. The reciprocal would be ugly and wouldn't even be something we're going to do. It's just a tool that I came up with to help you graph it. This black graph is not part of our function. It's part of this function. The blue graph is the only part of the original one. Let's do one, and then we'll probably that's all we're up now. Okay, so let's do y equals 2 cosecant of 1/2 x. You want a phase shift or not? Plus 3. I'm going to make at least a nice phase Okay, so we're gonna ignore this function, and we're gonna graph this related function. And basically, this is all a bunch of scratch work, and isn't really part of the answer to the cosecant graph. This is just a function to help us get to that cosecant graph. So the related graph. Y equals 2 sine 1/2 x minus pi over 2 plus 3. All I'm doing is changing cosecant to sine. And by the way, we don't have time today to do a secant graph, but a secant one will be very similar, but you'll change secant to cosine. And then you'll just do the same thing, work across your center line, have your vertical asymptotes. Okay, so again, all this information we're going to write down here is for the related graph, the stuff we've been doing, such as, let's start with period, 2 pi divided by 1/2, 4 pi, making our x scale markers pi. Good. What else? Phase shift. Pi over 2 divided by 1/2.
Is it just
Pi.
pi, negative pi?
No, remember the negative doesn't go with this. Dx minus c.
Oh,
I was trying to do pi over 4, but
it's just pi.
yeah, it's just pi.
Pi turn.
Oh, wow. Okay. That's to the right.
The transfer.
What else? Amplitude?
It's true. Changing that what it's like.
Phase shift? Oh, we already did that. I mean, center line? Okay, so let's graph that. We don't really need to know
But
the
yeah,
phase shift.
starts at 3. So 2, 9. So 2, 2, so it's
All right, so it's a sine graph. Let's see, the center line is y equals 3. So we normally start right in the middle there.
but we're pied over.
Pi to the right. At our next tick mark, which happens to just where full x scale mark is right here.
2
If you're
pi.
using pencils, make this light or dashed or something, because this graph is not part of our real graph. I'm going to use different colors. All right, now, everywhere we cross the center line, okay, so that was this graph here, that's what we needed. We didn't really need the information. But everywhere we cross the center line, we're going to get a vertical asymptote. And now we're ready to graph this cosecant here. So the cosecant, in between those two vertical asymptotes, it's on the same side as the center line, but instead of being stuck in here, it's inverted into a U. And it actually, they hit, okay, the high points are the low points, and the low points are the high points.
Oh shit, I went the wrong way.
Okay, if you're using pencil, this sign graph in the middle should be lighter or dashed or even erased when you're done. It's just a tool for us. This black graph with the U's going alternating up and down, up and down, up and down, that is our cosecant function. That was our goal. So this cosecant graph is this graph right here. Yeah, so you can erase it or make it dashed or something in the middle. This sine wave is just an intermediate tool to help you get our graph that we want. This cosecant graph. So everything we wrote down applied to the sine function, not to the cosecant function. I guess one thing doesn't. I do keep the period. The period is 4 pi. The only other pieces of information I want is my domain and my range. Now the range is usually easier. The domain here on these is